Good afternoon, everybody. Good afternoon, good morning, good evening, wherever you are. Fantastic event this, quite amazing, really. Um, so I'm going to talk about sort of zoom out a bit from the previous talks and talk about a sort of very high level thing that might be blindingly obvious to those of us in the geoscience community that work with extractives, particularly with minerals. And this is about what the world outside our community thinks about our business, and particularly the massive concern that is shown by some groups, and this is the media, the public, policymakers, and other scientists about geological stocks and the fact that we're going to run out. So, and this has been around for quite a long time. People like Thomas Malthus, the political economist, who first wrote about resources. He was talking mainly about agricultural resources in the 18th century, and then the Victorians with Jevons, and then in the 20th century, after the Second World War, the President Eisenhower's Material Policy Commission, and then I'm afraid old enough to remember the publication of Limits to Growth in the 1970s. All of these the publications that came out of these pieces of work made dire predictions about us running out of mineral resources of one sort or another. And then that sort of went away for a bit. And then in the millennium, it all came back again. And we got this sort of neo-Malthusian thinking about resources, what I've called depleted thinking about mineral exhaustion. Famously in David Cohen's article in New Scientist in 2007, when he calculated that we were going to run out of all sorts of things in the next 100 years. Our own august institution, the Geological Society of London, published an article called Limits to Growth Revisited in 2015, which made the same sort of predictions. And just last year, our colleagues in the Royal Society of Chemistry started a campaign called Elements in Danger, and I drew attention to the stat line under Elements in Danger. Did you know that your mobile phone contains at least 30 different naturally occurring elements? Natural sources of 6 of these are set to run out within the next 100 years, with several more under rising threat from increased use. Now, those of us working in this area know that this is simply not true. We are not going to run out of things in the next 100 years. And there are all sorts of reasons for that. But we see again and again in the media, again, as I say, from other scientists, from some august scientific journals, and from politicians, phrases like peat metal, elements in danger, getting rarer, reserves are dwindling. And they all compound this long-standing myth about the imminent depletion of minerals and metals. And we would contend, myself and my fellow authors, Paul Lusty and Mike Stevenson, that these assumptions are mainly rooted around misunderstanding of what resources and reserves are. And I'm not going to tell this audience what a resource and reserves are, but there are some working definitions that you could use if you like. They really are economic definitions, not physical definitions. And that's what the community of people outside our community really, really misunderstand. So those terms used by other scientists, the media, other people are frequently, generally used incorrectly. And our colleagues in the USGS give some good guidance on this. They say reserves are dynamic, and failure to appreciate this dynamic nature leads to erroneous forecast, because our friends and colleagues outside our community tend to look at a reserve figure and they do what we call a static lifetime calculation. They divide the quoted mineral reserve by the current or projected mineral consumption, and you end up with a number of years left. But we all know that resources and reserves are economic entities. They're working inventories that are only valid at a given time. And they vary according to the rate of extraction, new discoveries, plus a whole bunch of factors that you've been hearing about this week around the politics, the social, economic, and technical factors which affect the economic viability of those particular reserves and resources. And they're absolutely not a reliable indicator of future availability of minerals and metals. And if you ever wanted a diagram that shows that, this is a conflagration of data from our colleagues in the USGS, which is their reserves data, with my colleagues here in BGS in the UK who monitor world mine production of copper. And you can see there the grey bars are reserves from the USGS, and the copper coloured line is world mine production. And you can just see there how reserves have just kept pace. And you can plot just about every other metal, and it shows a similar sort of graph. And those of us working in this business know that and know that's true. So we know that the Earth's total endowment is much greater than current mineral resource and reserve estimates indicate. And we know that we will find more. There are undiscovered identified deposits. There are more exploration around known deposits. And really critically importantly, there are massive resources and reserves, or resources particularly at the moment, within the secondary and within our own environment, within the anthropogenic environment, that we will be able to recover as our economy becomes more circular. So you might say, so what? Well, we believe this is important because we're not. This is a distraction. This constant obsession in the media and in other groups around running out is a distraction from the real issue. The real issue is environmental limits, not physical exhaustion. So we're much more concerned that planetary environmental limits are being pressed by mineral and metal production. And there's some scary figures out there around primary metal production accounts for about 20% of global industrial energy use, or about 7 to 8% of total global energy use. That's a lot of energy. And therefore that's a lot at the moment greenhouse gases. So we can make some really big reductions in greenhouse gases by looking at the efficiency of mining, particularly the major industrial metals that we mine in quantity. So to finish, the running out stories, as I've called them here, are very appealing. The media love it. The number of times I've been asked, how much have we got left? When are we going to run out, by journalists? It's a pretty standard question. They're very good. They sell clicks and they sell print. But they are a serious distraction from the urgent need to relieve the environmental pressure on the planet. So my appeal to the geologists of you out there is, every time you hear a journalist or someone else talking about reserves wrongly, correct them, please. Tell them that they've got this wrong, because it's a major, major issue, I think. And just to finish, thanks very much. Just today, we published a science briefing paper on this very issue. So if you go to that web address, there it is. And it's literally only been up there 2 hours. So we just got there in time. Thank you very much.
Brilliant. Thank you very, very much, Andrew. So round of applause from all of us on our side of the microphones. And just before we come to questions, one question from me. So just to be sure, are you telling us that we're absolutely not running out of all of this? Is that the take-home message from you?
I think what I always say to people is, if you think the world's running out of metal, go to the prospectors shack at the PDAC and just see the number of people trying to sell deposits and prospects and et cetera, et cetera. Now, I think all the figures suggest that I am not complacent about this. And the previous speaker made the very, very valid point that things are getting harder to get at, and we're consuming more and more energy or water and other environmental impacts in doing that. So that's the issue. The issue isn't the amount of metal in the ground. The issue is the amount of effort it's taking us to get out. So I would argue that we stop worrying about we're going to run out of copper or we're going to run out of cobalt or whatever, and start worrying about what's the environmental impact of that, particularly greenhouse gases. because that's an existential risk facing us, and we need to do something about that. Stop worrying about running out of stuff. I'm not saying we don't need to keep looking, and we don't need to keep doing research, and we don't need to keep investing in all that, but we definitely need to disavow our stakeholders, I'm going to use that term, that of this issue, that the you know it, in theory, yes, the planet is a finite place, but if you think about it, the problem with our impact on the environment is not actually our impact in everybody talks about non-renewable resources. Minerals are a non-renewable resource. That's much less of an issue than our impact on renewable resources like air, like our atmosphere, like water quality, habitat destruction. They're much bigger problems for us facing now. That's what we need to focus our effort on.
So thank you for that. Thank you for that, Andrew. Something that maybe just builds on this whole discussion, and you're a brave man using the word stakeholder with regards to the chatter that's going on at the moment. But this is maybe something as well where perhaps words are getting in the way of meaning. And that's the case. So, for example, yesterday we heard from David Payne, who was one of the people involved in the UK minerals strategy. And the interesting thing around that was that's a document that's written more from the planner's perspective. And yes. So when we're perhaps seeing the words reserves being used in that document, it's around stocks that are available to the construction industry in the UK, which of course means something very different to somebody who's involved in, say, copper mining in Peru. So is this something here, Andrew, where do you think that when people are saying we're running out, there's an awful lot of misinterpretation and misunderstanding with regards to the words that we're using?
Yeah, I think there is. I think one of the problems is that our community use these words in different ways as well. So we have to be, one of the arguments we make in this paper is to be more precise about definitions and clearer about. And my organization is as guilty as anything else, because we talk about resources all the time, and we don't mean resources in the sense that a lot of our company colleagues talk about resources. So it is very difficult. It's fraught. The semantics in this are very difficult, but I do think that fundamentally there is a problem with people misunderstanding what the issue is for our resource use. It's not about physical exhaustion. It's about the impact, the indirect impact of our resource use on non-renewable resources like the atmosphere, like water, etc. And it really worries us that policymakers, particularly people who make the laws we all have to work by, keep coming back to this. And there's a lot of concern about that, and it's not. We need to really change their view on that.
Brilliant. Thanks, Andrew. There are a couple of questions that are coming in, and you're going to have to bear with us in terms of whilst people sort through this whole running out thing. So we need to address these questions. One question here is from Nick, and he asks, I've been told that one element that might run out is helium. Is there any truth in that?
That's the one that does float away if we use it, whereas everything else theoretically doesn't. I mean, I'm not an expert on helium at all. I think it is probably one of those things that we have to be more careful about how we use, but it's the exception rather than the rule, I would thought.
Okay, thank you for that. So hopefully that answers your question, Nick. We've got another question in here that says we're actually running out of cheap metals. Whereas high-grade deposits seem to decrease within world production. Do you want to just comment to that one?
Yeah, I mean, I think we are. I think we've inevitably sort of high-graded the planet, really, and we need to now think about and as grades decline. I mean, grades decline for other reasons as well. One of the reasons copper grades have declined is we're working porphyry copper deposits, which are low grade, but they're more suited to the sort of style of mining we do. But I think that we are, there are thermodynamic limits for some things that I mean, platinum is the obvious one where we're possibly approaching the thermodynamic limits of what it's possible to extract from rock. So I would still say fundamentally the metal is down there. It's whether we can afford the environmental cost and that is wrapped up in the economic cost of working it. And you could very strongly argue, and I'm sure a lot of people on this conference will agree, that the price of metal does not reflect the true environmental cost of production.
Oh, exactly, and I think that this is something here where we could go back to a lot of what Nadia said in the previous conversation to say, actually, where do you put that true value on those assets? And then this morning, some of the information that Zach and Aidan were sharing with us around, yes, what is that whole value with regards to an asset, not just now, but through its life cycle as a whole.
Yeah.
So brilliant. Thank you very much, Andrew. Massive hands together from behind our microphones as a whole. That's absolutely brilliant.